Okay, this video is about piecewise functions. So a piecewise function is a function that is defined in one way using one equation or formula for part of the domain and a different formula in another part. So for instance, let's say that you had something like f of x equals 1 if x is less than 0, and 2 if x is greater than or equal to 0. So what this means is when x is negative, f of x is 1, and when x is 0 or greater, then f of x is 2. So a graph of this will look like this. So here's the positive x-axis, here's the positive y-axis. So when x is negative, the y value is 1. So here's 1 and here's 2. When x is negative, the y value is 1. So it's like this. Up, and I have a hollow point here because at 0, at x equals 0, the y value is not 1, it's actually 2. F of 0 is 2, and then when x is greater than 0, the y value is 2. So that's what the graph of this function looks like, and it goes out forever. Okay? That's what this function looks like. That's one example. Let's do another example. Let's say you had x if x is greater than or equal to 0, and negative x if x is less than 0. This is an important piecewise function. So what does the graph of this look like? So when x is greater than or equal to 0, I want to graph y equals x. So for this part, when x is greater than or equal to 0, right, this part, I have the graph y equals x. So that looks like this. Right? It goes on forever. And when x is negative, I have negative x. So I have y equals negative x, and it's like this. And that goes out forever. And this is the absolute value function. Right, that's what the absolute value is. When x is greater than or equal to 0, it doesn't change the function, but when x is negative, you multiply it by negative 1. So the absolute value can be, the absolute value of x, this function, f of x equals the absolute value of x, can be written as a piecewise function. And this is important, and it's used when, well, it's usually used to deal with absolute values. You split it up depending on whether the inside of the absolute value is positive or negative. Okay, so that's an example of a piecewise function. Let's look at some more examples. Let's say that you had a more complicated example, like x plus 1 if x is less than 1, and when x is bigger than or equal to 1, it's x squared. Okay, how do we graph this? Well, it's one thing on the left of 1, and it's another thing to the right of 1. So here's x equals 1. And I'm going to have one graph to the left of the line, x equals 1, and another graph to the right. And together, that's going to make the graph of f. So I want to graph y equals x plus 1. Let's just look at the graph of y equals x plus 1, because that's what I have. That's what I have here. Okay? If you have the graph of y equals x plus 1, let's just forget about the piecewise part. Let's just graph y equals x plus 1. Well, if you graph that, that's just a line with slope 1 and y-intercept 1. So that's this, right? This is y equals x plus 1. And let's graph the other one, y equals x squared. So that's this parabola. It's like this, right? Now what you want is, you want the line when x is less than 1, so, okay, so here's x equals 1. You want this part to the left of x equals 1, right? And to the right, okay, to the right of 1, you want x squared, because f of x is defined to be x squared when x is greater than or equal to 1. So here's x equals 1, say, and you want this part to the right. And notice that for the line, I have a hollow circle at x equals 1 because I don't want to include the point when x equals 1 because the line is only relevant when x is less than 1, right? Notice that when x is equal to 1, I need the parabola because of the greater than or equal to sign, right? Okay, so now we just want, on the left of x equals 1, we want the green line, and then on the other side you want the blue parabola. Okay, so now we're ready to graph the function f. It looks like, okay, well when x is 1 on the line, you get 2, right? So you have this line, so here's y equals 1, and you have this line. So that's what the graph looks like to the left of 1, and then to 1, well when x is 1, what's y equal to? F of 1 is equal to 1, because 1 squared is 1. So I have this, and then I have the parabola, which looks like this. So there, that's the graph of the function f of x. See, it's in two pieces. Now in this example, the pieces don't line up. They might line up, but in this case, they don't. Okay. And of course you can, it doesn't have to be broken up only at one place. So you can have something like, f of x equals -1 if x is less than 0, and when x is between 0 and 2, it's x minus 1, and then when x is greater than 2, it's like the square root of x. Okay, let's do this example. So I see that this function is broken up into how many pieces? 3, right? I have one thing to the left of 0, I have another thing between 0 and 2, and then another thing when x is bigger than 2. So let's draw the axes. So I have one thing when x is negative. Well, that's easy, it's just -1, right? So that's not hard to graph. It just looks like this. Hollow circle to indicate I don't want that point. And when x is between 0 and 2, I have x minus 1. So, okay. X minus 1, that looks like. Now you could practice, do I have a, so I want something I can easily erase. But if you want, you can just graph y equals x minus 1 like this, right? And then you only keep the part, you only keep this line between 0 and 2, when x is between 0 and 2. So then I can just like erase this part, and then just keep that. So then it will be, okay, I don't necessarily recommend this, but if you wanted to, you could do that. So it's going to be like this, right? And now you fill in the circle because when x is 0, y is equal to -1. Okay. And on the line when x is 2, I get y equals 1, so this point is 2 comma 1. So let's just label this. So this is 0, -1. This point is 2 comma 1. And then when x is bigger than 2, I have the square root of x. So the square root of 2 is square root of 2, that's like 1.4 something. So that's like, let's say it's over here. Right? So then I have an empty hole, a hollow hole, and then I just have the square root of x. Remember, the square root of x, when you graph it, it looks like this, right? And it goes on forever. Okay, let me okay. So I obviously don't want this part. Right, the square root of x goes out forever like this. But I only want the part when x is greater than 2. So my graph is going to look like this. It's going to go on forever. So that's what my graph of y equals f of x looks like. Okay. So one common mistake I see is that sometimes students, when they graph like an x equals 2, they'll start, instead of taking the whole graph, so a lot of students will know that the square root of x looks like this, but then when they're told that, okay, you start when x is 2, they'll move this like over here or something and then do that. When in reality, what they want is this piece, right? So that's a common mistake that I sometimes see. Okay, so that's pretty much it about piecewise functions. And you can have a function that's the domain doesn't have to be all real numbers. I mean, you can have something like 1 over x if x is positive, and then when x is negative, it's negative 1 over x. Well, what is this going to look like? Okay, so when x is positive, I have 1 over x, so it's going to be this graph. So this is a graph you definitely, that's not good. This is definitely something you want to make sure you remember, that it's going to look like this. Right, it's going to stabilize to y equals 0, and it's not going to touch y equals 0, but they'll get, in some sense arbitrarily close, and then there's going to be a vertical asymptote of y equals 0 here, so that's y equals 1 over x, and then negative 1 over x. Well, if you just had 1 over x, it would be like this. So this would be the graph of y equals 1 over x, but then you want negative 1 over x, so you want to flip across the x-axis. You want to multiply all these y values by negative 1, so then when you multiply a y value, like let's say this is y equals negative 3, you multiply by negative 1, you get positive 3. Right? So what happens is this piece gets flipped over across the y-axis, across the x-axis, and so what you end up getting is this. So that's what the graph of y equals negative 1 over x looks like when x is negative, and so this is the graph of f of x. Right? And notice that the function is not defined when x is 0. Okay, so piecewise functions are definitely things that you want to make sure that you're familiar with. They show up in calculus, usually in the section on continuity, because continuity is about basically the function is in one piece. So if you have a piecewise function, like in this example, the absolute value of x, the function is in one piece. It's not broken up anywhere, but in this example, it is broken up. Right? It's broken up here. So you would say, here you would say that the function is discontinuous at x equals 1. because the graphs don't line up. But here, the graphs do line up at well, everywhere. So here you would say that this function is continuous. Everywhere, or that's the same as saying at every real number. Yeah, and it also shows up in the context of derivatives sometimes, because derivatives is a type of limit, and you have like these one-sided limits and so on. So piecewise functions sometimes show up there. Okay, so that's what you want to know about piecewise functions. You want to know what they are, and you want to know how to graph them and what they tell you, and how to figure out the value of the function. And then one more thing is, colloquially sometimes people say that this function is like two functions. Well, it's really one function. I mean, a piecewise function, this f of x, like in this first example, okay, it's one function. It's just that the description you give of the y value is different from one piece to the next, but it's still one function. Okay, thanks.